All right, fundamental theorem of calculus is going to allow us to find basically an unlimited number of rectangles underneath that curve. Now remember what I just showed you before we did this. If some of the rectangles are above the curve and some are below the curve, this isn't going to take that into consideration. Those below are going to be negative, those above are going to be positive. They will kind of cancel each other out. So you have to be very careful. But it is quite simple. You notice earlier when we had this little, it is kind of an S symbol, there were no little pieces here, A and B. Okay, that was kind of called indefinite or not defined integral. This is defined from one place to another. Did we kind of have that with the rectangles? Did I tell you to go from here to there? I did. I said a lot of times, what, 0 to 2, 0 to 1. That's the only place I wanted you to do the rectangles. And so what we're going to do is we are going to take the antiderivative of some function. And all we're going to do then is substitute b in, substitute a in, and subtract the 2. That's it. That's all the more difficult it is to basically find a bazillion rectangles in there and just get the answer. So let's just do it, and then we'll graph it. So let's just take the antiderivative of 2x. It's been a while since we actually did an antiderivative, so it might take you a while. So it's basically 2x to the second over 2. Now, seeing there are numbers here, right? You do not write plus a constant because it's not asking for general answers. This is asking for a very particular solution here. What are you going to get from 0 to 3 is what it wants to know. So you don't have to write plus a constant here. But I think we can agree that those cancel. And what a lot of people say is, okay, we got x squared now. They say this squiggle that was out front turns into a straight line. This is how some people write it, and I want you to see it. And then the 0 goes here, and the 3 goes there. Because the 0 was on bottom before, and the 3 was on top. Okay. Now what this rule up here is saying is basically this is kind of A and that's B, right? Do you agree with that as far as the setup here? It's saying put 3 in. Find out what you get. When you put 3 in, what do you get? 9. And it's saying then subtract whatever you get when you put 0 in. 0. 9 minus 0 is 9. That's the area underneath that particular object, whatever it would happen to be. That's how easy it is. That's actual. They put in so many rectangles that it would find it for them. But let's take a look at what you just did. Let's just graph this just for curiosity. 2x, y equals 2x would be a what? A line. And I said to go from where to where? 0 to 3? So 0, 0, right? Do you agree that's a point? 1, comma, 2, 2, comma, 4, 3, comma. Do you agree that's all the further? Yes, I could extend it. Y equals 2x is a line, right? The only reason I kept that dark is I only told you to go from 0 to 3. And I told you that right out front, 0 to 3. So basically, you just found the area of that. You just found the area of a triangle using calculus. Okay, because this is 3. This is 6. Right angle. Base times height divided by 2. You get 9. Okay. Obviously, I chose some that graphically are very easy at this point to show you that it actually works. Do you have a question? Okay. On this one, it's 3. I like to do this one because sometimes people forget how to do this antiderivative because it's so almost so easy it's hard. What is the antiderivative of 3 with respect to x? 3x. And what did I say? That squiggle, that is kind of an S, turns into, a lot of times a straight line is how it does get notated. And so I want you to see it. And so took the antiderivative. What I got to do now is you always put the top one in first if you were going to ask that, because subtraction is important, which order you do it. So 3 times 4, well, that's 12. minus whatever you get substituting in the bottom one, which happens to be -3. So it's 12 minus a -3, in other words, 12 plus 3, which is the left side of the y-axis doesn't matter. It's when you go below the x-axis that's a slight problem. So wait a minute, it's y equals 3. What's that look like if you graphed it? Horizontal line, yeah, at 3. 1, 2, 3, 4. So basically, it is to the x-axis. You just found the area of that rectangle using calculus. Because how tall is it? It's 3, 5, let's see, 1, 2, 3, 4, 5. I think we'd agree that's 15. Again, I started you with some simple ones. You could draw in that entire line if you wanted to. Okay. And let's face it, doing rectangles on that one wouldn't have been that hard because it's straight across. You could have just done, would have been pretty easy. But again, I want to start you off with some visually easy ones to prove to you it's working. And let's face it, this really isn't that hard. Right? But it's like derivatives, start off pretty simple, and it gets a little more complex as we go. So this one is the first one where it's actually a parabola. And doing it with rectangles will only give us an approximation. So why don't you take a second and try and do that one. This is one of those where those parent graphs that we did, it helps you a little bit to have some clue of what this would look like. But let's just do the antiderivative and see what happens. Antiderivative flat out is what? Okay, or x to the third over 3. Yep, so 4x minus x to the third over 3, or you can write it 1/3 x to the third, and then from 0 to 3. Now, here's where it gets a little more difficult. This is the first time we had two pieces in there, right? What you do is, here's how I write it. You definitely don't have to write it this way, but you can. I basically put 3 in kind of separately. So I put 3 in this first one over here, and you get, I kind of do it like this. I say, okay, 12. And there's a minus kind of built into this problem right there. Do you see? Right there is where this minus is coming from. So put 3 in there, and we get 3 to the third is 27 divided by 3 is, so do you agree that's what I get just by plugging in 3? That's kind of how I write it. And that's how I remember what I get. So now I have to do minus whatever I get for plugging in 0. It's just a way I organize it, so if I look back, I can see maybe where I made a mistake. You're going to learn to really like zeros in these problems, because a lot of times you're adding variables to things, so having a 0 is always a nice number to have. Because putting 0 in there, pretty simple. 0. Okay, there's a minus built into the problem, and then 0 in this other one is, again, 0. So yeah, you're going to learn to really like zeros. And so, in essence, this whole second half really wasn't too important in this problem. And so we get 12 minus 9. Are you slightly suspicious of that answer? Well, let's take a look at the graph then. We got, well, what is 4 minus x squared? In general, it's going to be what? Parabola that opens kind of down, and it's been moved Up how much? 4. Yeah. So you know 0, 4 is at least one of the points. And it does open down. And seeing this problem asks from 0 to 3, let's just worry about that. And so basically if you plug in 1 or substitute 1 in, what do you get? It's 1 comma 3. All right. You substitute 2 in, 2 comma 0. You substitute 3 in, 3 negative 5. So is that what you get? All right. Well, well, here's where it gets tricky. What you're always finding with this is area basically from the curve to the x-axis. So I'm finding that, and I'm finding that. You're always finding the basically area from the graph to the x-axis. And that's why I put this one towards the end to see what we would have. Now, did the directions on this problem tell us to find area? No, they did not. They said evaluate each definite integral and graph it. If that's all it asks you to do, go ahead and do it. The negatives are just going to cancel out some of the positives. That's what definite integrals can do. That's what it knows how to do because it's adding up all those rectangles, and it sees these rectangles as negative. Okay? Indefinite is when you just take the antiderivative and put plus a constant, and there are no numbers. That's what indefinite means. It means not defined from one place to another. John? Okay, I get exactly what John's saying. In fact, it was a question I was going to ask, because basically here's what it boils down to. I wrote them down somewhere. That this area, just this one, is 5 1/3. So I was kind of happy that some of you were like, wait a minute, how can this answer possibly be 3? When you looked at your graph and you're like, there's no way that's just 3. But this question's not asking for area. It's asking for indefinite integral. So you go ahead and let it do it. This one right here is negative 2 1/3. So does the answer come out to be 3? It does for this problem. Now the very next question that's on the other side of your paper is which of the previous examples would have a different answer if the directions read to calculate the area. Well, I think we could agree that this is the one that would have a different answer if we were told to calculate area. All right. What would be the answer to this problem if we were told to strictly calculate area, not finding indefinite or the definite integral? This one, and what would the answer be? 7 2/3. You would add them together. And I think what John was getting at is couldn't you kind of just find the answer from 0 to 2, find the answer from 2 to 3, and then just add them together? You can do that. You can separate it and say, okay, I'm going to take the area from 0 to 2, and then over here I'm going to do from 2 to 3. This answer right here is going to be negative 2 1/3, but you know for area you just make it positive if that's the question. You have to really read directions and see what's being asked. Basically, I did this. I went from 0 to 2 of that, found that answer as 5 1/3, and then I did 2 to 3, found it was negative 2 1/3. And that's how I found those answers, is by actually separating them to find out where does it go. All right. So please be very careful. At the very beginning, I'm going to ask you for just do definite integral to get used to the problem. Okay, the AP itself loves to flip that back and forth all the time. One question it'll ask area, the next one it'll ask for the integral, and so you really have to be careful. Okay. Any other questions? Those have all been very good ones. All right, what's next? Oh, there it is. All right. For example, this one says evaluate the following definite integral. Graph the function to support your answer. So is this one asking for area? No, it's not asking at all. But we do have a problem. Yeah, it's absolute value. Does anybody remember what that parent graph looks like? It's a V, very good. And the plus 2 is on the inside, so what happens to this one? Okay, move to the left. I heard a lot of different answers there. I heard left 2, right 2, and up 2. And now Taylor just wants to add down 2 to the mix. If it's inside, it's right or left, and it's the opposite of what you think. So it is actually left 2. Okay? And so if I were you, I would get a kind of a graph of this thing. And the nice thing is on x is where you normally find slope, and so the slope of this is going to be 1 this way. And so we go like this. I'm just graphing it so we get an idea because I'm going to have to show you something on this one. And so what's the slope going this way? Well, it better be -1. And so there's the entire graph, looks something like this. I'm being asked to go from 0 to negative, or -4 to 0. So here's -4, so there's 0, correct? Here. I'm just showing you the graph so because there's something I have to show you on this one. Yep. We have to do this somewhat differently. So we're basically looking for that area there and that there. It doesn't. The problem is that particular function, if I just had to graph just that portion of it, is different from that one. That's a problem. Close to its reciprocal. So here's what we're going to do. Do you agree from -4 to -2, though, it is all the same graph? And from -2 to 0, it's the same graph the whole time? Well, who thinks they know what is the equation that would actually give me that graph? Forget about that one on the right. What would actually give me that one right there? Well, it'd be -x. So y equals -x. It would actually hit at -2. Yep, -2 is that function. How about this one? Y equals x plus 2. Very good. So what you have to do, because have we talked about absolute values as far as taking an antiderivative yet? No, that's because you kind of have to split it into 2 functions, depending on where you're given. So this one, again, is right there. So what we're going to do is for that one, and this particular equation goes from where to where? It goes from -4 to -2. So I haven't asked you to write the numbers in yet. I'm going to see if you've been paying attention. It's from -4 to -2. Where's the -4 go, on top or bottom? Bottom. -4 to -2 of that will give me part of my answer. The other answer is taking x plus 2. What numbers should I put in this one? Yep, bottom's -2 and top is 0. So once again, why don't you take a second to get a little more practice on this and try those. All right, for sake of time here, why don't we take a look? And I'll be pretty honest with you, I probably would not do the calculus on this one to find the answer. I would just find the area of the 2 triangles and add them together. But I want to show you some simple ones that you can see visually and show you how the calculus works so that when you get to harder ones where you can't do it visually, you'll have some idea of how to do it with the calculus. And so, yeah, we know that one's there. All right, we'll get rid of that. So your antiderivative for this one, negative x squared over 2 minus 2x. Again, from -4 to -2. All right, and then we'll just do it down here real quick. This one then is x squared over 2 plus 2x from -2 to 0. What'd you get for the top answer? 2. What'd you get for the bottom answer? 2. Add it together, you get 4. So if we put 0 in, let's check it out then. 0 there and 0 there means it's 0 minus whatever you get for plugging in the bottom one. Put -2 there and square it. +4 divided by 2 is 2. Put -2 right about there. -4. 2 minus 4 is -2. Put a negative on top of it is a +2. So, what if I gave you the problem slightly differently didn't give you the function at all. Only gave you the graph. And I asked you to find the definite integral for this problem, say from -2 to 4 or something along those lines. I gave you the graph, did not give you the function, meaning basically I didn't give you that at all. It said find the definite integral from -2 to 4. Is that something you should be able to calculate on this particular example if I gave you that graph? Yeah, if I ask you for that, from -2 to what, 1, 2, 3, 4, I think is what I said, is that something you should be able to calculate right there? Okay. Here's what the AP really likes to do. They like to throw different problems out there to see if you actually get the concept. Can almost everybody that takes the AP actually do that problem? Yeah, and actually once I show you how to do it on the calculator, it's going to take you about 3 seconds to do that on your calculator. But they want to see, do you understand the concept? And is this concept of that area for that blue triangle we just made really that hard? Not really. But you have to understand all the words they put in the question. Okay? So if I would have said, what's the definite integral of this graph from -2 to 4? That's how they would word it. Is that something you should be able to do? Yeah. Okay, so keep that in mind. Are there any other questions?